The Law of Diminishing Marginal Returns, Part 2, Expanding on the Widget Simulation, a Short-Run Exercise, a Keystone Lesson in Microeconomics by Eric Almeroth. Remember this? The widget factory production table, where marginal product and marginal returns was shown in the third column as we produced widgets. Our first worker brought in an additional 4, the second worker an additional 5, the third worker an additional 6, the fourth worker an additional 7. Inefficiency had not set in yet because specialization and division of labor was making us more efficient with one stapler as we continued to expand output. But then, at this point, adding another laborer, we saw diminishing marginal returns. Total returns was still increasing, though by less, and when we added a sixth worker, we saw more diminishing marginal returns, even though total returns was still increasing, until the seventh worker when we saw diminishing marginal returns and also diminishing total returns, as we went to -1. So next, let's look at average product. What is the average product at each level of input, and how do we figure it out? To learn about averages, we will first apply them to total product. The following numbers are a textbook example and do not apply to the widget table numbers. Physical product, 1. If 5 laborers produce 15 total units of product, what is the average amount of units per laborer? 15 divided by 5 equals 3. If 10 laborers produce 25 total units of product, what is the average amount of units per laborer? 25 divided by 10 equals 2.5. Number 3, if 15 laborers produced 30 total units of product, what is the average amount of units per laborer? 30 divided by 15 equals 2. As you can see, averages were determined by dividing the total number of physical product by the quantity of laborers. Next, we'll apply averages to total revenue. Total revenue is total product turned into dollars, or turned into a dollar value. If 5 laborers generated a total revenue of $15, what is the average revenue per laborer? 15 divided by 5 equals $3. If 10 laborers generated a total revenue of $25, what is the average revenue per laborer? 25 divided by 10 equals $2.50. If 10 laborers generated a total revenue of $30, what is the average revenue per laborer? $30 divided by 15 equals $2. As you can see, averages were determined by dividing the total revenue by the quantity of laborers. Let's do one more. Next, we'll apply averages to total cost. Total cost is the expense of producing the total product expressed as a dollar value. If total cost was $15 with 5 laborers, what is the average cost per laborer? 15 divided by 5 equals an average of $3. If total cost was $25 with 10 laborers, what is the average cost per laborer? 25 divided by 10 equals $2.50. If total cost was $30 with 15 laborers, what is the average cost per laborer? 30 divided by 15 equals $2. As you can see, averages were determined by dividing the total cost by the quantity of laborers. The average is always found by dividing the total number on the curve by the amount on the quantity axis directly beneath that number or amount. So now that you know how to do averages, let's figure out column 4, average product, on the production table below. What is the average after 1 laborer? 4 divided by 1 is 4. 2 laborers. 9 divided by 2 is 4.5. 3 laborers. 15 divided by 3 is 5. 4 laborers. You got this. 22 divided by 4, 5.5. 5 laborers. 27 divided by 5, 5.4. 6 laborers. 30 divided by 5 is 5. 7 laborers. 29 divided by 7, 4.1. So let's look at the average product and marginal product curve. Let's first check out the average product curve we just entered into the widget table. X-axis is quantity of labor, Y-axis is widgets. And this is what the graph for average product would look like based on what we just put into the table. As widget laborers became more efficient, the average per worker increased. Average product eventually decreased due to the inefficiency of diminishing marginal returns setting in. Next, let's observe how the marginal product curve influences this average product curve. Marginal product is the top curve, average product is the less steep one on the bottom. Whenever the additional unit is more than or above the average, it pulls the average up. If a new student enters the class and has a higher score on an assignment than the average score, this score pulls the average up. If the marginal or additional unit is the same as the average will remain the same. If the marginal or additional unit is less than the average will decrease. Therefore, the marginal product curve directs the shape of the average product curve, not the other way around. And the marginal product curve will always intersect the average product curve at its highest point, which you can see it doing here. A more textbook version of the average product and marginal product curve will look like this. You can see where the marginal product curve is above the average product curve is drawn upward. As soon as the marginal product curve crosses below the average product curve, it's pulling it down. The average product curve will be the mirror image of the average cost curve. And there is a similar relationship here. The marginal product curve will be the mirror image of the marginal cost curve. But notice that when the marginal cost curve is below the average cost curve, it's pulling it down. When it's above the average cost curve, it's pulling it up. And the marginal cost curve will always intersect the average cost curve at its lowest point. Because of specialization, increasing labor efficiency results in increasing per unit labor of output at first. This increasing labor efficiency also results in lower per unit marginal costs at first and lower average costs. Then after diminishing marginal return sets in, average product begins to decrease and average costs begin to increase accordingly. These two curves paint a very clear picture of this concept if you can get them to talk to you. The average product curve is increasing at first and then decreasing. The average costs are decreasing, which is a good thing, and then increasing in accordance with how the average product curve is working. So you begin with one laborer and you start making widgets. Then you add another worker, then another, then another, and another. About this point and the next, you begin to notice your workers are getting less efficient and your costs are increasing. What are you going to do if you want to produce more and do so efficiently? That's right. Expand the capacity of your business. This is the short-run average cost curve we're looking at here. Buy another stapler and move into the long run and begin another short-run cycle as an upsized business. This second cycle here indicates you've gone into the long run. The Law of Diminishing Marginal Returns, Part 2, Expanding on the Widget Simulation, a short-run exercise, a keystone lesson in microeconomics. The